Hi, I'm Mr. LeBlanc, and today we'll be doing another video experiment about slippery roads. And here's our scenario. There's a lot of ice on the sidewalk, and you know that salt works to melt ice. Normally rock salt is used, but yet you don't have any rock salt for your road or sidewalk, and so you look for an alternative. And so as you see here in front of me today, I do have a bag of rock salt, and here in a cup here I have rock salt, but this is a little bit different actually. This is a little bit, it's called calcium chloride, which is a version of rock salt. And I don't know if you can quite tell there, but the crystals are much larger than a normal salt that you would have in your table shaker in your house. The other material, and so there's two other materials we're going to use here for today for our experiment. But first of all, we have that question that we need to answer ourselves. What substance can be used to melt ice faster? And so for our experiment, we are going to be using ice cubes to be able to answer this question. So there on your worksheet that you have listed there in front of you, the next thing on your paper there for you to do is to fill out the materials that you have for your experiment. So one of those is going to be ice cubes. I would suggest using an ice tray so that way you can get every single ice cube to be the same exact size. And so that way there's an equal amount of milliliters per ice cube for each and every single one of them. Now I use that term milliliters. You can go ahead and use pints or cups or tablespoons, whichever size, but eventually you're going to convert everything to say milliliters using a translator from customary to metric for your experiment. So ice cubes is one of them. As well for ours, you're going to list sugar, calcium chloride, also called rock salt. You're also going to have, here for your experiment, we have 3 trays, 3 plates to be able to put your ice onto. As well, for my experiment, I actually have here what's called a graduated cylinder. You most likely don't have one of these at home, but instead you can be able to use one of these that you have here to be able to find out the exact amount of water that's going to melt as a result of these materials. So let's go ahead and first of all, before we begin our experiment, we need to decide what is our independent variable here for our experiment. Well, remember, your independent variable is a thing that you're going to be changing. So what do you think we're changing here? Well, we're actually changing the material that is going to melt the ice. And so I have actually 2 here, but we already know rock salt is a very effective means to be able to melt ice. But the other one that we're not so sure about, because like I said, you don't normally have a bag of rock salt. So instead, I have sugar. Will sugar actually melt the ice faster than just ice being able to melt by itself? So that's what I'm changing. The material to melt the ice is going to be is the material I'm going to be changing. What am I going to measure? I'm going to measure how much water is able to melt from off the ice. And so obviously we have an equal amount of water starting off for all of them. But what's going to change is how much is still in solid form versus what's going to be in liquid form. So that's what I'm going to be measuring. I'm going to be measuring how much ice has changed to liquid form. Then you're going to list your controls. You're going to have all of the plates in the same place. I'm going to be using my refrigerator to be able to do this, so that way it'll be more like being outside, because outside it's not going to be a perfect 72 degrees. It'll be cooler. So my particular refrigerator is at 37 degrees Fahrenheit, which you would of course want to convert to Celsius when you do your experiment. And how do I know this? Well, of course I would put a thermometer inside of my refrigerator. My door says 37 degrees. But of course, I would want to verify that to make sure. So that is one of my controls. I'm going to have an equal amount of grams of sugar versus rock salt. Now, it'd be great to have a kitchen scale to have the right amount of grams or the amount of pounds for it. But instead, I'm going to be using, instead a very, very small amount, I'm just going to be using half a teaspoon, which actually equals right around 2.5 grams, as you see converted there on your page, because I've already listed out almost all the procedures for you on your paper. The next step that you're going to do, though, before we start getting into all the procedures here, is you need to come up with a hypothesis. Which do you think is going to melt faster? Rock salt or sugar? And you're making a decision about, or if you say which one is going to melt the most ice the fastest. Now, the ice is going to melt no matter what because we're putting the refrigerator, not into the freezer. But which one is going to melt it the most? And so for your experiment, though, you're going to choose something different besides sugar to be able to try to find a material besides rock salt that would be an effective means to be able to do it. And I would even suggest being able to come and try a few different concoctions that you can be able to make up from your house. You're like, well, I don't know what would be able to work. Well, this is where your research comes in. Your research is always done before all your procedures are done because your research helps you to know what kinds of things can be able to melt water faster than just room temperature or the outside air. And so what kinds of materials will be able to do this? And so that's some of the material you'll be researching. And you can find out what each of these different materials are made up of and what would be the compound or the chemical inside of it that would be able to help melt it. So now that we've done some research on different materials that would be part of our experiment, such as I made mention of the word calcium chloride, those would be two very important words. I've listed several other words there on your list that you would want to know about to be able to be effective in knowing why rock salt works, why sugar works to be able to melt, or does sugar actually work? We'll find out here in just a minute. So now we go into our procedures. So procedure number 1, it says get the salt, sugar, 9 ice cubes, and measuring teaspoons ready to use nearby. So as you see in front of me, I have all those things ready to go and be able to do it. I've already placed my ice cubes onto my tray here in front of me, and so they're ready to go, ready for me to be able to get my measurements out. So it says into each 3 bowls, place quickly 3 ice cubes. Arrange the ice cubes so they make a triangle on the paper. Carefully sprinkle 1/2 teaspoon of salt over the cubes. And so go ahead and on my first one here, and it will be on the brown plate, will be where I place my rock salt. So there's my 1/2 teaspoon. You could always measure, like once again, doing this way or by weight, be able to do that. So I'm going to sprinkle that and try to make sure to get as much of it as I can right onto the ice there, so that way it has the most effective means. And then I'm going to place half a teaspoon of sugar onto my orange plate here and place it right over my ice cubes here. And finally, I have my water, which of course will have nothing in it. That will be one of my controls to be able to see is water, of course, will melt in there. And I want to see will one of these other 2 materials help it to melt faster. My next step here now is to be able to empty a shelf and have a shelf ready to go inside of that. So I'm going to go ahead and pause here and get that all put into the refrigerator, and then I'll be back here in just a moment to be able to see which one has melted the most after a period of time. And so one of the important steps here before I go ahead and pause here is it says when the ice cubes is in one of the bowls has become at least half melted, take out all 3 bowls from the refrigerator and move on to step 5, because I am not measuring the amount of time it takes to melt all the ice, because we're not looking to measure all the ice, we're just looking to see which one is able to melt the most ice. And so we're looking to see when at least has been melted at least halfway, which one is going to have the most amount of milliliters that has changed to liquid form. And so I just wanted to remind you that we're not looking for it to melt completely in the refrigerator, because that could take quite a while, especially at just 37 degrees for the refrigerator temperature in Fahrenheit. So we've taken all of the ice cubes out of the refrigerator, and you probably can't tell from the picture there, but they have melted about halfway at least on them. So we've taken them back out of the refrigerator, and we're going to go ahead and find out exactly how much it's melted. One thing we should be doing during this sort of time is be looking at it and seeing, what do I kind of notice in the picture here about the different materials that I have onto it? One of the things I noticed on the rocks there, for instance, is that there's actually some puncture holes of the salt that has actually gone all the way through the ice and has actually melted through the piece of ice. Whereas the sugar is very much still on top of the ice cubes, whereas the rock salt has all sunk below the ice and is no longer sitting on top of it. Then, of course, our water is just a puddle of water there from the ice cubes there as well. And so the next procedure, it says there, and it'll be kind of important you follow through with this. I gave a little more detailed list here of how these procedures work. And this is what I'm looking for if you decide to do a different experiment besides the experiment about the icy roads. That you should have a very specific list of exactly how the experiment is done, so that way somebody else could be able to replicate your experiment to see, are your results valid by following the same exact steps. And so the more detailed, the better the experiment is generally going to be thought of by us as teachers and for the judges for the science fair. And so, as the procedure says, it says when the ice cube has become at least half melted, take out the 3 bowls from the refrigerator, move on to step 5. It says step 5 is actually going on to step 6. Carefully pour the liquid from one of the bowls into the cup with a spout, such as a large measuring cup. So now we're going to go ahead and pour the water into the large cup. And that's going to happen sometimes. The ice cube is still going to fall in there, so we're going to scoop that back out there. And we're then going to pour it into the graduated cylinder. And we're going to see how much liquid is actually there. And so I look at my liquid here and I look down. Remember to know the meniscus, which is at the lower point. So this comes out to 20 milliliters of water. And then I'm going to pour the liquid into the water cup, so that way I have it out. And I'm going to do the same thing now for the sugar. So I'm going to pour it into the large cup. So. And I'm going to pour, this is empty now. We should dry it out if you were doing very specifically, but I'm wanting to make sure to get the results as quickly as I can. And this comes out to be right at 20 milliliters as well. And so I'm going to pour that into my sugar cup. And lastly, I'm going to do my rock salt. I'm going to carefully pour that into this. And each time you should really dry out your the cup before pouring it into the cleaner cup, so that way there isn't other deposits there from the other ones. And so I poured it into this one. I'm going to pour that. Obviously, first of all, I need to get a measurement from this, and it comes out to be at 36 milliliters. And so I've recorded those 3 numbers down. You would record those down on your table there. But that's just part of it, because there's still more liquid in these cubes here. So I'm going to stop the video here and I'm going to melt them down the rest of the way to go ahead and see what the result, the total result is, because we have to do some math here. Now I have let the ice melt all the way down so that the way they're completely liquid. I'm going to now take the water. I'm going to put it into my larger beaker first and measure how much water I have left. I take my measurement there, and so the rest of it comes out to be right around 14 milliliters. And I'm then going to do the same exact thing for the sugar, water. I'm going to take that measurement, and I'm going to pause here. I'm not going to actually pause the video, but I'm going to stop the process right here, because to be able to do the next part of the experiment, it will be the same for both the water, the sugar, and the rock salt. Is that I said that the water was 20 the first of all, and then there was 14 milliliters of still remaining ice that was left. And so we add those two numbers together and we get a total of 34. And as your instructions say, calculate the percentage of ice that was melted. And so what you would do there is you had 20% that melted, 14 milliliters that was left. So you would say 20 divided by 34, and you would get your percentage number there. And you would do the same thing for the sugar. Get the total of just the sugar water, and you get a total for just the ice. And obviously you could probably figure out already that our rock salt was the winner for the most melted, at least more than halfway melted. In fact, actually, our water did pretty well there as well over time there. And so, we could be able to see those results that came out with that. And our sugar there, obviously I stopped right there, so that way, did the sugar actually beat this rock salt or didn't it? And that's part of the experimental process that I want you to go ahead and find out. And of course, then you're going to give your observations that you gave from your experiment. And you're going to have to do this 3 times, remember. You're going to do the same exact thing a total of 3 times. And after you do this whole process once, you will dry everything out, start the same process, put it in the fridge, and do it a second time, go through the whole process again, and then do it a 3rd time. And you're having observations from each one of those to see if they were any different. And then finally, you're going to give a conclusion about what would be resulting from this. What did I learn from this? How would I change my experiment? And on your paper there, it gives you some suggestions about what you should write there. So I am looking for you to write that information down on that paper at this time. Lastly, we talk about the biblical purpose. And the biblical purpose for this can be, I would say, is one of the most evident ones of the different science experiments that we have for this year, due to the fact that salting our roads or using an alternative to it can be an effective way to be able to help save people's lives from slipping and hurting themselves, as well as maybe even finding a more environmentally friendly way to be able to do it. Because actually, some of the research you should find out is what kind of effect does rock salt have on vegetation? And that will be something important for you to be able to find that out as well. And so don't forget about doing your biblical purpose as well and making note about that, not only for this video, but also when you do your actual experiments, doing the biblical purpose about why I'm doing this science experiment.